Hello guys, welcome to my YouTube channel. So today I'm going to be talking about unit tests. If you're new to this channel, please subscribe, like this video, and share if you find it informative. So today I'm going to be doing a tutorial on how to write unit tests. I'll be covering all the concepts, and I hope that you'll get a lot from this tutorial. So in my code I have a small Spring Boot project. It has a topics controller for availing the API to the user. Okay, so the project also has a data transfer object DTO. They also have a model for the database, so known as an entity, and the entity has 3 fields. So it has the ID, name, and description, and it auto-generates a primary key, a key that is auto-generated when being persistent of the database. It also has a repository that extends the JPA repository and accepts a topic where the ID for each topic is long. Okay, so and also it has a service, and in this service I have two services. One is the calculator and the other one is the topic service. So the topic service, I'll come and do unit test for it, but I've created this calculator to show you how to carry out unit test using a simplified version which is easy to follow. So in this calculator service class I have two variables declared, so int a and int b, and it has a constructor. Remember, a constructor has no return type, and it has two methods, the add and the minus. So when writing unit test, you must first know what the test is doing, what the method is doing. So in this case, if I have to test this class, I'll write unit test for this method and this method. Unit tests are among the smallest tests you can do on a piece of code, and they are most of the times actually isolated from the main system, so they can be run individually. So I can run unit tests for this code, I can run unit tests for this code without running the other one. So when you are writing unit tests, the main aim of writing unit tests is to ensure that in future your code might be working today, but in future if someone else comes and changes a bit of the logic, and the logic does not produce the desired output, then the test should fail. And when the test fails, whoever is making that change in that time, as of that time, will be able to know where that test is failing, and the test will show that it has failed at a certain line of that code. So he or she can then make changes so that the code or the modifications do not interrupt the operations that was set before for that code. So a test can fail and a test can pass. A test that does not have an assertion will also pass. So if your test does not have an assertion, it will likely pass. So for you to create tests, you must create a separate class. So under the test package, remember under Java we have the main package, and we have the test package under SRC. So whatever is in main, we can create tests for it under tests. So when you are creating a test, first you need to create a separate class for whatever test you are running. So in this case, we are creating a test for the calculator class. So we are going to, under the now the tests uh, package, we create a test calculator test. So it's good to add the word test so that whenever you are running it, or whenever someone else is interacting with your code, he or she can know that this is a test. So I've already created the test class, and let's go to the test class. So this is the test class. So you see it has the package declaration. This is where you import the package that is being used for this class. Then we have the imports. So the before each import, the test, the inject mocks. Now I'll tell you what these are, but these basically are the testing framework imports. So these are imports for the frameworks we are going to use to test our code. Now the reason why we are using frameworks is that in some instances we may not want to actually do the operations. Let's say something wants to add something, we want to mock that. Let's say something wants to do an operation in the database. We want to mock that operation, we want to simulate that operation. We don't need to actually do it, because assuming you have a user's table and it has data, adding test data to your live database or a database may not be needed, may not be required, it may lead to inconsistencies. And that's why we need frameworks, testing frameworks. And one of the frameworks, we have the JUnit, and we also have Mockito. So in this video I'll be doing testing with JUnit and Mockito. These are robust testing frameworks. And so let us dive into testing concepts. And as I say that we use these testing frameworks to do that simulation. So we don't need to actually do whatever is in the code that you are testing, because in tests we are not replicating the code, we are not creating that, we are not creating the code that exists and duplicating it. We are just trying to simulate how the actual code would run, provide the values for that code, and define what it should do when the actual code is called, and then test the output. So in our case, if you go to this class, so we have this inject mocks. So under inject mocks, whenever you want to test a class, you mock it. In this case, we are injecting all mocks for the calculator class. Okay, so if this class had external services, we would also mock those external services. Let's say it was using other interfaces, we would come here and mock those services. So something like at mock then that service name, we would mock it like that. For now it is not using any services, so I'm going to remove this and leave it the way it is. Then here, after you mock, you inject those mocks for that service you are testing, and we're saying you are testing this calculator over here under service implementation. So when you inject those mocks, now you avail those mocked, all that is mocked, you avail it and register that with this open mocks. So this before each is an annotation that tells Java that before running any test, do this, do ABCD. Before doing the the addition test, do ABCD. Before doing the subtraction test, do ABCDs. So you can actually initialize your variable here if you want, but in my case I'll be initializing the variables for each test individually, so that each test has its own variables initialized when it's run. Okay, instead of having all the tests initialized, all the data initialized always, or when we are running all the tests. Now in this case, we have annotated, there are three annotations. Is the at inject mocks, which I have already explained. There's the before each, which ensures that before each test is run, something is done. Maybe you can initialize, you can set up something, or you can do something. So in this case, we are calling Mockito annotation dot open all the mocks. Then you are passing what do you want to open. You want to open the mocks on this class, and this class is the calculator test. So we are passing these mocks for this calculator, and we are opening them using this open mocks. Okay, so then we have the test add. So when you are testing, when you are doing unit tests, there are three main things you must do. First, you must know what you are testing. You can test the behavior of a method. And how do you test? You test by, if you know what a function or a method takes in, and you understand what it does, then you can predict what it will give out. Actually, if you know what it does, you don't need to have static data, or you can have any data, you know what it will process it to, and then you know the result. And if you know the result, then you can test that when I provide these results, does it actually give me those results, the expected results? In our case, in our addition, we know that the addition function takes in uh, two variables, int a and int b. So we know that it shall returns a sum. So if we return 2, if we add 2 and 3, we know that it will return 5. If it returns to us 6, then we shall know that the method is not working well. And that's where tests come in. So we can test whether does it actually, if given 2 and 3, does it return 5? If it does not, then it should fail. And the test shall tell us that it has failed. Let's go to the calculator test. So in test, there are three things you must know. You must always arrange. So a test has three sections. Most developers don't need to comment this, but the parts are the arrange, then the act, and the assert. In the arrange, you actually give your test the data. You give the data that you use to test the actual code. So if you are testing addition for two integers, then you need to provide two integers so that now you can use that data to test. You can also provide mock data for your test. This is for operation you don't want to do. You don't want to read from the database. So the way you could have read from the database and got data, now you can, instead of now reading, you know what the data you expect a string or you expect an integer, you can just assign that data to a variable so that it serves as a mocked data for your test. So that is where we put the data, and it's the arrange. So the arrange gives variables for your test. That's where you prepare your data for the test. Then remember that this test data can be anything. It cannot be an integer, it can be a list, it can be a custom data type, it can be an object you created by yourself. Let's say you have a student, so you can say student is equals to new student, then student or set name. Then now you can use that as the data. You can prepare that data under your arrange section. The next section after arrange for any unit test is the act. The act is where you pass in the data you prepared for your test. So in the act, you are trying to see that whatever data you have, if you pass that data to the function you are testing, here we are testing the AND function, and the reason we are calling calculator is because this method is declared as static. So if I go back to this calculator, you can see it's a static method, so you don't need to initialize something like a calculator. Calculator is equals to new calculator. You don't need that. With static methods, they belong to the class, and that's why I can call this using this class name calculator. So in my test, I have directly called that class calculator. Then I can access all the methods that are declared as static. So dot and, then I've passed in the test data. This is A and B. This is 2 and 3. So we expect that this result over here should be equal to 5, and that is where I added this mock data of 5. I could, instead of using 5, I could actually write A plus B, but in tests we are not usually trying to create more code. We are just, if we actually know the data, we can just assign it. But if we don't know, there are some functions that you may need to perform a bit of operation actually in the test so that you can get the data you want. For example, comparing the sizes of 2 or more variables that you want them to serve as test data. So you might have to add them as part of the initialization and declaration so that you can get this data. So now this sum, remember we have two results. You cannot test one thing. When you are testing, you are doing a comparison. So that comparison is referred to as an assertion. So the last part of every unit test is to assert. You assert that, is it behaving the way it should be? Is it giving us the result that it should give us? So that's the assert. Now under the assert, you can assert many things. You can assert if there is a value. So I could assert that assert not null, assert not null, assert that it's not empty, sorry, assert that it's not null. So I could come and do the sum. So here we are trying to see whatever is provided here, does it fulfill the condition that we have set for it. For now I'm going to remove this. Okay, and back to this test. So when you are asserting, you are compare two values. So the first value is the expected value. So we expect that 2 plus 3 is 5, and this is the mocked value that I've added as a sum mock. So that is our expectation. That's why I say that when you're doing the unit test, you must know what it does, because if you don't know what it does, you can't be able to create a test for it. So we know that this method adds, and we know that when 2 and 3 are added, they will give us 5. That's the sum. So the expected value is 5 for this test with this provided data. Now this result we don't know yet, because now this is what we are testing. We are testing this result, this sum, from the calculator.add, where we acted to get the result. Now this result should be equal to this, and if these two are equal, then this test should pass. And so for this test is actually based on the fact that these two values are equals. So you can have more than one test for the same function. You can have more than one unit test for the same function, because I said you can assert whether it's null. You can assert, so you can add another test and say test add when null, so to check null, something like that. So in the assertions, that's why you do your actual proving. You prove that whatever you are testing returns the data that is expected, So if it returns an integer, then it should be returning an integer. You can also assert that the object types sum and sum are equal. Sum, assuming this was a list, we could assert that these two are equal, okay, of equal data types. So we can also assert something that is an operation that returns true. You could come and assert true. Assuming wanted, you could assert true, then the result. But in our case, we can't do that because this is not a boolean. So if it were to be returning true or false, you could assert true or you could assert false. So that's the basics on unit test. The last thing I want to say is that when writing your unit test, always ensure that these methods are the avoid methods. So test methods do not return. Okay, so all test methods are void, and these methods are annotated. So in my case, I've annotated a test, but this is just a short form of the package that is testing. So this test, we could actually add this awk.api.test before each test. So I could copy this and I could come and place it here like this. It will still work, but you cannot mix at this full path with this, so you must choose one. Okay, so whenever you run your test, you can run the test for the whole class. So if I click on this, I'll run all the tests. So I have two tests, the addition and the minus test. The addition and the minus test. So it shall start building. So when it builds, it will tell you that the two tests have passed or the two tests have failed. Okay, so and the reason the test may fail is if the data in those tests, so as you can see, it's instantiating this test. The top error, this one is not related to the test, it's just an inbuilt error for the IDE. Now you can see that these two tests passed. So let's make our test fail. So if we were to change this input, okay, we changed this one to 5. Okay, assume a developer is working on your code and he changes this value, and assume there are many codes over here, and he does not change the actual the expected result. Then we expect if you run this test add, it should fail. So let's run it and see. So, and the reason it will fail is that the sum mocked will be 5, but the actual sum will fail. And to show you that assertion is an assertion failed, and you can navigate to where it failed. So the expected is 5, but it found 8. And it found 8 because the result calculated out at a plus b gave 8. Okay, so assuming you are writing this code, you have two options. You can either change this or you can change this. Now in your code, you'll also need to check your code. Let me open now the calculator test and the tests we are testing. So you see now this is what you are testing, and you can see it shows you that it failed. This is where it failed. Okay, assertion failed, and that's how you write unit test. Now when you go to the second test of subtraction, you need to arrange data. So you prepare the data for the test, so int a, int b, then you create a mocked result. In this case I've indicated this so that it can calculate for us. You don't need to calculate, you can just provide the value that you know, because you know what it's doing. Then now I'm asserting that the subtraction result equals the result of that function equals the results that I have mocked. Okay, so I have written two tests. In my next video I'll be doing a test for a service that is connected to a database, and I'll be showing you how you do those tests. So as I finish, let me fix my test. So let me 53 equals 8, so you know it shall be 8. Then I can run my test, and it runs, and the test should pass. Yes, so the test has passed with a greens, and that's it. That's how you write unit test for your functions in Java. Thank you for watching. In my next video I'll be covering unit tests for topic service implementation. Like this video, share, and that's it, and see you then.